From my previous lecture, it was x belongs to n, a is a inverse, and we had a one line here. What is this? X a is a inverse, x inverse equal to a is a inverse, and this implies a inverse x a is a inverse x inverse a equal to a is, and this implies a inverse x a is ax a inverse x a whole inverse equal to a is, and this is implies a inverse x a is belongs to n a's, because n, what is the definition of n a's? N is equal to all those g such that g a is g inverse equal to a is. N is equal to all those g such that g a is g inverse equal to a is. So a inverse x a belongs to n a's, and this is implies x belongs to a n a's a inverse. So if x belongs to n a is a inverse, then a belongs to a n a's a inverse. So this is implies n a is a inverse is a subset of a n a's a inverse. N a is a inverse subset of a n a's a inverse. Conversely, if suppose x belongs to a n a's a inverse, so similarly this implies a inverse x a belongs to n a's, and we give the previous reverse imply, you obtain x belongs to n a is a inverse. So by the reverse implies we get a n is a inverse subset of n a is a inverse. So these two we get n a is a inverse equal to a n is a inverse. Now we have another example or exercise. Let a's and k be subgroups of a group G. Prove that a's is a normal in K if and only if A is subset of K subset of Ng of A's. Okay, this is your homework. Now there is another exercise. Then NGAs and NGK are conjugates. H and K are conjugate, then we have to show NGAs and NGK are conjugate. Since H and K are conjugate, then H equal to G, K, G inverse for some G belongs to capital G. And this implies N is equal to N, G, K, G inverse. Normalizer of A is equal to normalizer of G, K, G inverse. K is a subgroup and for some G belongs to G. And this is implies by previous result G, Nk and G inverse. Okay, so Na is equal to G for some G, Nk, G inverse. This implies Nas and Nk are the conjugates. Nas and Nk are conjugates. Now we discuss about the conjugacy class of S3. S3 is a simple group, the permutation group S3 of order 6 equal to order of S3. In the group S3 has 3 conjugacy class, namely 1 2 3, this is identity, and 1 2 3 and 1 3 2 and 1 2 1 3 2 3. Then the class equation of S3 equal to order of Z of S3 equal to summation G is to CA, where A belongs to A minus Z of S3. So this implies order of S3 equal to 1 plus or order of Z of S3 plus order of CL12 plus order of CL1 2 3, and which is 1 plus 3 plus 2, and this is 6. So 6 equal to 1 plus 3 plus 2. There is a note. Two cycles in Sn are conjugate if and only if they have same length. That means 1 2 and 2 3 they are conjugate. Similarly 1 2 3 and 1 3 2 they are conjugate. And also there is an important result: if n greater than equal to 3, Z of Sn equal to E. Z of Sn equal to E for all n greater than equal to 3. Now we find out the class equation of S4. Consider S4. The elements are how many elements in S4? In S4 has 4 factorial elements, that means 24. Okay. E 1 2 1 3 1 4 2 3 2 4 3 4. These are the length of 2 cycles. Now 1 2 3 4, this is product of 2 cycles, 1 3 2 4 1 4 2 3. Now the 3 cycles, 1 2 3 1 2 4 1 3 4 1 3 2 1 4 3 1 4 2 and 2 3 4 2 4 3. These are the 3 cycles, and the 4 cycles are 1 2 3 4 1 2 4 3 and 1 3 2 4 1 3 4 2 1 4 2 2 and 1 4 3 2. These are the elements of S4. So the class equation of S4 is mod of S4 equal to mod of Z of S4 plus CL12 mod of CL1 2 3 4 plus CL 1 2 3 plus mod of CL 1 2 3 4. So we can see that this is 1 plus 6 plus 3 plus 8 plus 6, this is equal to 24. This is the class equation of order S4. Now the question is how to find how many cycles of order product of 2 cycles. How many cycles of product of 2 cycles? For that we have a proposition. If sigma is an m cycle in Sn, then the number of conjugates of sigma is n into n minus 1 dot n minus m plus 1 divided by m. That means in S5 how many cycles of length 3 is? So m equal to 3. So 5 into 5 minus 1, 5 minus 2 divided by 5, that means equal to 20. This is the result to find out the number of m cycle. But the question is how to find how many cycles of product 2 or product 3, whatever may be. For that there is important result, this result from Damit and Foote. Let sigma be a permutation in Sn and let m1, m2, ms be the distinct integers which appear in the cycle type of sigma. For each I belongs to 1 2 dot dot s. Assume sigma has ki cycles of length mi, then number of conjugates of sigma is n factorial divided by k1 factorial m1 to the power k1, k2 factorial m2 to the power k2, ms into ms factorial ks factorial into ms to the power ks. This is the result. n factorial divided by k1 factorial into m1 to the power k1, k2 factorial m2 to the power k2 dot 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 ks factorial ms to the power ks. This is very important result. For using this result, we can find out any class equations of any essence. So first of all, I show an example of which is S5. Okay. S5 has 2 cycle, sigma equal to 1 2. Okay, first of all we can see that 5 equal to 5. Actually, we can see that representative of conjugate classes, how they looks like. That means how many cycles, how they form. Is there 2 cycle, 3 cycle, or product of 2 cycle, product of 2 and 3 cycle, product of 2 and 2 and 1 cycle. So how to find? So for that 5 equal to 5. That means this is a partition of 5 equal to 1 plus 2 plus 2 equal to 2 plus 3 equal to 1 plus 4 equal to 1 plus 1 plus 3 equal to 1 plus 1 plus 1 plus 2, and this is equal to 1 plus 1 plus 1 plus 1. That means 1, 2, 3, 4, 5, 6, 7. This, the representative of that is the 5 cycle means, the 5 cycles means 1, 2, 3, 4, 5. This is means, this is product of 2 cycle and 1 cycle. Product of 2 cycle and 1 cycle. That means 1, 2, 3, 4. This is a product of 2 cycle and 3 cycle. 3, 4, 5. This is a product of 1 cycle and 4 cycle. That means 1, 2, 3, 4. This is a 1 cycle into 1 cycle into 3 cycle. That means 1, 2, 3. This is 1 and 2, and this is the identity E. So now, since S5 has a 2 cycle, the number of conjugates of 1, 2 is, we can use the previous proposition, which is 5 into 5 minus 1 divided by 5, which is equal to 5 into 4 by 5 equal to by 2, this is equal to 10. Similarly, we can find the conjugate of 1, 2, 3, conjugate of 1, 2, 3, 4 by similar result. So 5 into 5 minus 1 into 5 minus 2 divided by 3. So this is equal to 20. Similarly, this is equal to 5 into 5 minus 1, 5 minus 2, 5 minus 3 divided by 4, and this is equal to 30. Okay, and the number of 5 cycle 1, 2, 3, 4, 5 is equal to, by similar way we get this is equal to 24. And the question is the number of 2 cycles, the number of conjugate of 2 cycles, which is, that means 1, 2, the conjugates of 1, 2 and 3, 4. We use the previous important result. This is equal to 5 factorial divided by 2 factorial into 2 square, because 5 factorial by k1 factorial into k1 square into k1 factorial into m1 to the power k1. So this is equal to 15, and 1, 2 and 3, 4, 5, that means the number of conjugates of product of 2 cycle and 3 cycle is 5 factorial divided by, this is 2 length is number of 1 length is 2, number of 2 length is 1, and number of 3 length is 1 also. So that means 1 into 2 to the power 1 into 1 into 3 to the power 1. So this is equal to 20. So number of class equation of S5, that means its order is 120. So 120 equal to 1 plus 10 plus 20 plus, that means CL of 1 2, CL of 1 3, order of CL of 1 2 3 4 plus 30 plus 24 plus 15 plus 20. Okay, and you can check the sum of that is equal to exactly equal to 120. So this is the class equation of 150. So using this result, we can find out the class equation of any SNS, where n is greater than equal to 3. Okay, so today we stop this class. Thank you.